What's that? Were you at? I was in Kirkland for extended. Let's see. Probably don't want showcase. Okay, so how do I? You online? Clive? Clive. 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 Make sure he joins the hangout. What email can I send the invite to? JAT at what? I still didn't catch that, but I will.
Oh, look right there.
What's that? It's JAC.
Yeah.
There you go.
So now,
You've got an email, join that hangout, and mute your microphone when you get in there. You're going to be talking through that earpiece into ours. Yep. And then, yeah, it'll join. So mute the microphone. Otherwise, we'll get a bad feedback loop. Not that one. On here. So click allow. Go ahead and click allow. It's fine. At the top right of your screen there. See how there's an allow above you? Right here. Yep. Okay. Now mute that microphone right here. There you go. You have to hit the join button. Hit join. Clive, now have him share his screen.
So we couldn't keep doing it.
You're good.
And the next guy was doing like this sort of meet up, find your friends app thing, and he's talking about running events and all this other stuff. And somebody asked me, like, "Well, what's your business model? How are you going to make money?" His answer, "Well, we haven't really figured that out yet. We've got enough funding to last for a couple of years." Oh. And the next question was, "I've heard that it's difficult to get funding. How did you do that without?" The answer was connections. I just wanted to use this. You kind of just, yeah, it's like, all right, that's great. Why are you talking? Why am I even dealing with you? How hard work. Yeah, it's like, you're, what am I supposed to do? You're an example for the rest of us. Grow up and be a douche, you know? Yeah. I was a little upset about that. Not very early, but
What's the matter?
you know, and I'm trying to circumvent a lot of ways.
Hello.
Hello, everybody. Welcome to the meetup tonight. So we have two live talks, and then we have our main talk. Kubernetes, thank you. Okay. Hey everybody, my name is Stephen Bowles. I hope you guys are having a great night. If you bring your attention to this website right here, Bellevue Tech Hive, I have a project management for it. It's in conjunction with the City of Bellevue and River Resources. We're having a hackathon on Labor Day, May 1st, 2nd, and 3rd of September, I should say. And we're going to be doing it at Bellevue City Hall. I'm basically here to get some boots on the ground to see if the developers are going to board on Labor Day. I can't imagine one would be. But if you are, that's what we'll be holding the event. The theme for this year's event, it's the inaugural event, is Global Good. We're actually going to be focused on people who want to hack together something that's going to be useful for either the community, the environment, the world, something positive. Not necessarily nonprofit, but definitely doing some for social good. We're going to have a couple of good, we're going to have a good conjunction bringing in entrepreneurs from China. We're bringing in a company called Alaska Life. They are working on an MVP right now. their MVP is actually doing urban farming, but in steel storage containers. And so we're bringing them over here, and we thought the best idea to bring them into Bellevue City would be to have developers, designers, UXers, anybody, troublemakers, whatever. We're going to have them work together on some ideas that can really bring them to fore into the North American marketplace. So I'll also put a link on Alaska Live later on this evening when I get back home. But basically, I have a bunch of cards with my information on it. The website's right here. When I go home, I'll put it on www.techguide.com. So if you guys would like to sign up, there's a contact form right up there. And feel free to get in contact with me as well. If anybody wants a card, raise your hand. I'll go ahead and pass one out. Otherwise, thank you for your time. I hope you guys have a great night.
So, very happy to introduce Jose. People have seen Jose. So Jose, over to you.
So anyways, if you download the SDK for the Google app engine, you get a bunch of demos, and the demos are pretty good for starting out. One that doesn't have is called Hello. Who's familiar with these demos? Hello app. So you get a lot of cool demos that you start out with. It doesn't have a good just plain old web, hello web for the demo. So I just made one myself that wasn't not really hard, but the good part about that is that it wasn't too hard. It's just a few files that help me set up a server. Then I can expose it to the server, and then I can do my web application. So I don't even know Go application very well, but I do know it well enough to be able to be able to do these tasks. And also I'm a front-end developer, so a lot of stuff is front-end. I don't want to spend tons of time with back-end. The Go back-end has been really big. Probably actually learn the language and also just get going with the web server. So these are the files that you can just go to get download them. The whole idea is that okay, Chrome. I don't know. I had the whole demo on another computer. But anyways, the idea is you can get Chrome, put it in local, and then you say go app, boy. It's like go app, server app. These are the basic files. I had an app YAML.
Ulimada benar musun Jeff? Takashi, Takashi. Takashi, 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 Takashi. Don't do it, Jeff.
Architecture where you have loosely coupled bits of functionality that you can move around very easily, swap in and out, and connect them to each other at a very broad scale. And now you're thinking about these pieces of functionality instead of the actual machines or the actual libraries or the lower level bits that you shouldn't have to care about. So why do care about containers? Well, this is a slide from Docker's Intro to Docker talk, and it kind of outlines the usefulness of Docker and containers in general. So this is the transportation industry, and you have every service provider out there who makes goods that makes different stuff. Some people make beans, some people make bananas, some people make a piano. If you're the piano company, why should you invest your time making a crane that knows how to lift pianos? You know, if you're a bean maker, why should you care about making a truck that carries beans? When you use something like the standard shipping container, if you're the goods provider, the only thing you worry about is sticking your stuff in this box. And then there's this whole other set of industry and tools geared around using this common interface to transport, store, maneuver the containers. And so you're not thinking about the logistics of how your goods are going to get from one place to another. You just stick them in a container and trust that they'll get there. And buy insurance in case your ship runs into an iceberg or something. So similarly, Docker has open sourced a library and tools for creating containers that operate in much the same way. So you as an application developer, you make your database, you make your front end, you make your back end, you make, you know, whatever bits of functionality that you need to run in the cloud somewhere, and you stick them in a box. And then that makes a clean separation of responsibilities where now the infrastructure providers can do all kinds of stuff with it. We can make tools. We can scale these up. We can start more or start less. We can move them from one place to another. We can put them, you know, on your private machine or give them to us. There's a whole realm of possibilities that are unlocked when you orient around the container abstraction. So you're not thinking about the raw hardware anymore. So Google knows a lot about containers. Everything at Google runs in a container, and we've actually been using containers for about a decade. So we're very well versed with the benefits, some of the pitfalls, and a lot of the different ways of organizing with and dealing with containers. One of the things that they've allowed us to do is achieve a very high level of resource isolation. What this means is that we can run two different tasks on the same machine. One of them could be a very high priority task, like a web search front end, or something that's crunching numbers for the news, or crawling the web, or something like that. And you can have a job that's an intern's toy project that you don't know what that's going to do. Normally, if you were managing things at a VM level, you wouldn't want to put those two things on the same machine, something like very important and something that could potentially break very easily. But what containers allow you to do is run them on the same machine and give them different priorities and, potentially kill one of them. Each container can pretend that it owns the entire machine and that it owns the world. And you've created a new kind of fragmentation for each of these environments. And you don't have to care what else is running on that machine. So at Google, we actually start 3 billion containers per week. So 2 billion containers per week. And that comes to around maybe 30,000 containers an hour or something like that. It's a lot of containers. So we're starting these up and down very quickly. We're killing them. We're moving them from one data center in China to a data center in Southeast Asia or something like that. And we're very well versed with using them, and we have a lot of experience. Search and Gmail and everything that you use at Google is running in a container somewhere on Google's worldwide distributed fleet of machines. So here's the critical missing piece is for you, the developers, once you have containers, it opens up a whole new way of managing your applications and using the resources available to you. Now you can overcommit your machines. You can have, instead of each developer having their own VM for testing, you can put a container for every developer onto one VM, and they'll share that CPU. You can share those resources and be more efficient. You can tune your environment. You can have an operating system that's very highly optimized for running these containers, and then you can put whatever you want in your box. Your continuous integration is now really easy. You start a container somewhere, run the test, see if it passes, tear it down, no sweat, no side effects, and every time you start that container in an integration environment, you know that that's how it's going to work in production. So it gives you very good reliability in that sense. And on the same topic, it gives your actual deployments in production a kind of robustness that you wouldn't otherwise have. Because whereas before, if you just give us a VM image to the infrastructure provider, that's a big black box to us. We don't know what that operating system is doing. We just know that it's using the CPU. That's the most we can tell you. Whereas now with a container, if your code starts making like 30 file descriptors a second, or it's just like blowing up the file system, we can tell, and we have monitoring for that. And we can say, hey, developer, you're using a lot of file descriptors. Is this intentional or not? If it's a bug, maybe you might want to fix it, but otherwise, carry on. You might want to know. And it's self-healing, which allows you to, if your machine goes bad, there goes all your state. You can pop it back up on a healthy machine, and it's as if you never left. But to make this work, we need to engage the developer community, and we need everybody's kind of help in thinking about how do we want to use containers as kind of a public resource. As we develop these newer tools to use them, we need them to become standardized, and we need them to meet the needs of people out there. We need them to meet the real needs, because there's a lot of bits that require kind of coordination and organization, and it would be a wasted effort to have a lot of the same tools provided by lots of different people, and they're all in different levels of support and have like a fragmented set of features. So what we're trying to do is really help everybody band together around containers and make a common set of tools that are, enterprise grade, good for actual live serving, wide scaling, agile development. And we need everybody's help to do that, because we can't just ask Google dictate what everybody should do, because, nobody's going to just do it that way. People are going to do whatever they feel is best for them, and we want to kind of meet everybody halfway. So now talking a bit more technically about how the container stack works here at Google, and what we're trying to provide to the open source community is we have kind of this scheduler level, which will take your container and schedule it somewhere. And on the machine, what you have is a scheduled container on top of a container manager that's on top of a managed base OS. And in the new world where everyone develops on containers, what the platform provides, what Google infrastructure can provide, is these bottom two nodes here. The managed operating system, where we handle your kernel upgrades, we patch your security holes, we provide a just clean slate for running containers on, and we provide a container manager to facilitate kind of the orchestration and allocation of containers on a particular machine. And we can do things here like rolling over your logs, or just doing some kind of basic maintenance for you, so you don't have to do some of that stuff. So here's an example of creating a container on Google Compute Engine. This is an Nginx container, and it's pretty easy. You create an instance called my Nginx container, and you get a metadata that's a configuration from a file in a zone. You can pick anywhere in the world to run this container. And you pick your machine type, and then you give it your Docker image. And then all of your application bits are in that image. And then your configuration over here, what it does is it maps a port from the machine to a port in the container. So when you write your server, you always write a server that's listening on port 80. In the container, all the ports are yours. All the file system is yours. You can pretend that you're on your own machine, but you're actually not. So we have this layer of translation to help route requests from the outside world, the actual machine that has a real physical port Ethernet connection, into the container that has kind of this abstracted away port where it's always running on 8080, or it's always running on port 80 for HTTP traffic. So what else you can do with containers is when they're isolated, you've kind of prevented any kind of resource sharing. But we provide this configuration bit to share resources on purpose. So you can have a mount in your operating system, say on mount shard, and when you write to that, you can configure it so that it's readable and writable from another container. So instead of kind of wildly sharing all of this state for the whole machine, you can pick bits and pieces to say, okay, this is shared, this is not shared. And the way we use this at Google is for crawling the web. You have a very high priority job that might be a www server that is serving requests from people who might want the news or the latest searches for something that's like kind of up and coming in the moment. And then you have a side job that is kind of crawling the web, that's slowly going out and accumulating information, and then it dumps it into this shared resource. And the front end can just always serve out of that shared resource, so it's getting fresh data every time. But they're different jobs, they're different containers, they have a different set of responsibilities, but you're always getting fresh data because of this kind of arrangement. So this is what it looks like inside of a host virtual machine. So we got the operating system, we got the Docker daemon, we got some tools that we're providing, and then the part that the user provides is just your container environment, which is whatever libraries you've installed in your container, whatever other bits you've decided to put alongside your app, and then your app, there's your code. So you don't worry about anything except just your code. So now let's talk about the meaty bits. So this is the stuff that we're trying to now provide with Kubernetes and a lot of our other efforts sharing our knowledge of how we use containers. Is you have a scheduler and scheduled containers on each machine. And the tool we have for doing that is Kubernetes. And it's Greek for helmsman of a ship. And I learned that approximately when Kubernetes came out. So what we want to do is right now, you take a set of machines that you have, and you probably have like pet names for them. You name your front-end machine Snoopy, and you name your back-end machine, whatever the bird's name is. But, we want to help you just think of all of your compute resources as like a big pool. It's just a big set of resources that you can allocate and fragment and just get as much as you need. And you can think about it as just stacking up all of your containers on a big cargo ship. So we're going to turn your fleet of virtual machines into a big cargo ship, and all you have to do is dump your containers on them, and they'll run, they'll host, they'll do what they need to do, they'll be properly connected, and they'll scale, because it's a big cargo ship. So how does it work? So Kubernetes gives you this view where all of your machines are homogeneous. So you have your machine, and you have an agent running on every machine, and it's the same agent. So you set up all of your machines to be like just Kubernetes pool bits. And then what we have on the side is a master scheduler. So you reserve one machine to be your master scheduler, or it could be provided by somebody else, and you just use the API, or however you want to interact with it. And then what you do is you say, hey, I have this pod. It's a container that has a server and a log roller, so that when the server's logs fill up, we can go save them somewhere else. And these both run in the same container because they share some state. You can just say, Kubernetes, I want to run this somewhere. I don't care which machine, I don't care where, just run this server. And it'll say, okay, and it'll run it somewhere. And so we find that when you make it easy to just create a container and deploy it, what people start doing is they make lots and lots of containers. And so inevitably the first thing that happens is that, well, yes, now you've made a big pool, but now you have like this big pool of all kinds of container pods all over the place. So what we need is a way to kind of organize them. So we have this concept in Kubernetes of labels. So you can say, show me all of the containers, all of the pods in Kubernetes that are running with this label of front end. And so now you just pull out all of the front end machines. And maybe that's not enough. Maybe you have front end machines in various stages of deployment. So you say, well, okay, I only want to look at the production front ends. Show me all the production front ends that are out there, and let me see what they're up to. And so what we can do then, once you're able to isolate a set of containers, is this interesting concept called a replica controller. So you can say, I want 4 copies of this container, and given it these labels. And Kubernetes will make sure that at all times there are 4 copies of this container running. And so it's continuously scanning and monitoring your pool. So say one of your machines goes off the grid. It's a bad machine, or there's a power outage or something. Kubernetes will go and it'll say, hey, there's only 3 instances of this front end running. Maybe I should start another one. And it'll start another one somewhere else, same container, same configuration, and it's self-healing kind of in this way. Say all of your front ends are running really slow, and maybe you need to allocate some more resources. Well, you just say, replica controller, I want to run 5 front end instances, and it'll automatically go find a machine to run a container on, deploy it, and it'll make sure that from now on there's always 5. And so this kind of gives you this management. Yes. The requests. Yeah. So you're asking how the rights within the servers. Yes. Yes. So there's some more features that Kubernetes provides that might address some of your questions. But the point of this slide, I guess, is just to show that if you want a certain number of copies of a certain piece of your service-oriented architecture to be running. You can create more, create less, and it will keep it consistent. So yes, here we said replica is only one, and Kubernetes killed 3 of them. And here we said replica 3, and it brought up 2 more. So what else it allows us to do is combine containers and create this kind of service interface that serves as a common interface to all of your containers. So instead of having to talk to a backend and say, I want to talk to this specific backend on this specific machine, we create this kind of abstraction where we know where all your backends are. We know what machines they're on. We know their IP addresses. We know their ports. And so why don't we provide a kind of common router and just expose a backend service? So you can just say, I want to send my request to this backend service, and it'll go to some backend. And that way, if the specific backend you were talking to before via a like static IP address or something goes away, you don't have to worry about that. And the scaling will kind of happen automatically without messing up your connection. And so this type of service combined with the kind of health management of your pods really enables you to rethink how you design your services. And the keyword here is, again, service-oriented architecture. And so you can have lots of modular bits that are behind a common interface that have a designated responsibility. Maybe these backends only talk to storage, and their only responsibility is to get some data and write it. And maybe you have a friend whose only responsibility is to read data from your storage and serve it. And maybe you have some other pods whose responsibilities are to do some kind of asynchronous intermediary computation. And so when you have these tools available to you, you're kind of free to get creative with it and do kind of whatever you want. It unlocks a whole new way of designing software. We want to enable the community to do. Yes. The whole idea here is already following the format. So one thing that I run into is problem kind of blamed offering. How am I going to move my stuff if we're talking? You have to kind of say, well, that kind of depends on how. In a sense, you could take everything that's currently in your VM right now and stick it into one big container, and then maybe split it up later. I mean, that would be very sad, but the infrastructure is very portable, and in that sense, I would kind of make the argument that it's worth the effort, because once you've uprooted yourself from the machine and gone onto a container, now it's very portable and you can move it around anywhere that you want. And actually getting it on a container in the first place, you can do something sloppy, but you can also do something like much cleaner and much nicer. So the sky is a lot higher for you. Yes. Yes, this is an out-of-the-box feature existing today. I'm not sure the exact algorithm it uses for balancing. Round robin, yeah. You address this backend service. So it provides a kind of small service. It's like a specific host port that then is a proxy for all of the other containers running. Yes, yeah, exactly. It does kind of some magic under the hood inside your containers to kind of connect them up to the service. The question is only from inside the Kubernetes system you can address it this way, or can you address it from outside? You can address it from outside too. Yeah. Yes. It's something like that. It's kind of taking some mappings and overriding them in the requisite jobs. But on these machines, there's a little bit of Kubernetes specific code running that provides the container manager and the container agent, and that does some kind of orchestration in collaboration with all the containers. Yes. All of the above. It's an entire Linux environment. You install any library that you want of any version, and nobody's going to mess with that version under the hood. And it's all of the servers that you start up. It's all of the processes that you want to run in the container. The OS is external to you. It's running on top of an operating system that's managed by, your provider, or by you if you want to be your own provider. Yeah, so the operating system is running, and it's running containers on top of it. So you get your virtual machine, and you have container daemons running on it, and they schedule containers to run on top of it. But the way that it works is it abstracts away the file system from inside the container. And so you can override any bit of the file system that you want, and you will see it in the way that you want to. And it's kind of an abstraction on top of the actual file system and what it really looks like.
If I may, so this is being recorded and it's going to be uploaded to YouTube. So if you do have a question, talk really loudly or make sure that you repeat that.
Yes, sorry, I will repeat the question.
Thank you.
All right. Well, now I'm going to do a demo of Kubernetes live. So let's do it. All right. So, all right. So what we're going to do is I've already started some machines. Let's use my cloud console. I'm going to go to my compute engine VM instances. What we see here is I have a Kubernetes master and a couple of Kubernetes minions. And the minions are my raw resources I'm just going to schedule jobs onto. So what I'm going to do is I'm going to create a data controller that's going to have two replicas, and it's going to map the external port 8080 to the internal port 80. So I have a container that's running an Nginx server that's listening on port 80, and it's going to tell Kubernetes to go start two of them and tell it how to map the ports so that HTTP traffic can actually reach inside the container. And look at that. There they go. Kubernetes made two of them. They loaded up, and they're serving a color. Serving just a random color of my choosing. And so once it finishes, there we go. And so this is a replica controller object that was created now. And so it has a version. It says how many there are. It says the ports, and it says the name of the image. This image is actually provided from Docker's servers. They provide kind of a GitHub-like interface where you can have a repository of your containers. You can just go store them there, and they can pull them down from anywhere that you want. So, if we're the boat, they're the shipyard. And so then what we can do is say, well, now I'm going to resize this data controller, and I want 4 of them. So make 4 of them, and oh, there they go. That's pretty quick. Now there's 4 front ends serving this color, And when they're black, that means that they're kind of in the process of booting up, and now they're all serving healthy. Yeah, you could. What you can actually do also is go onto the machine itself and kind of see it running, and just SSH. Oh, that's the master. You can SSH to any of them except that one. All right, yeah, so now we're on this virtual machine, and, normally I would have no reason to go in here. I don't want root access on this machine. I don't care what's running on it. But if I want, I can do sudo docker ps. I can see all the containers running on here. And here's my container, localhost 15 data. OBLX running an Nginx server starting 2 minutes ago. All right. So now what I can do is I'm going to edit the contents of the container. So I'm going to go to the data, and this is where the color is being served. And let's make this a more interesting color here. How about that? All right. And so now I'm going to build the Docker container using this new data. So now everything else about the container is going to be the same, except now this one bit of state is going to be different. And I'm going to push it to the Docker repository. So now I've made my container. I'm going to push it out to the shipyard so that we can get it from a central location. And this is functionality provided by Docker for managing and creating containers. It looks like it uploaded in chunks, and most of the chunks are the same. So this is it's a demo application. This is a demo application, and what it's doing is it's polling the master for where all of the containers are, and then it's getting their container ID, and it's getting their IP address, and then it's actually making a HTTP query for the JSON data, and then just showing that color. Yes. So yeah, that's just like a demo client to illustrate. Yes. All right. So now we've pushed the new Docker image. So now what we're going to do is we're going to do a rolling update on our data controller. And so because we've already defined the replica controller, it knows which containers I mean when I say go push this container to this replica controller. So it's going to take all of those copies of containers that are already made, and it's going to reboot them with this new configuration that I've given it. And you can see it's back here, it's killing the old container, and it's coming up, it's killing the old container. So reboot, and it'll come back up, and it'll initialize the server. All these servers have to start running on each of these containers. And here we go. This one is hosting a new code. Yes. Do they keep their IP addresses? The IP addresses of the virtual machines are the same. Yeah, but the pod's IP addresses change. Yes, this is the virtual machine's host IP address.
You've got a minus u 10 seconds there, so you're pushing these out and then waiting 10 seconds to push it out to the next machine. What's the default?
I don't know what the default is, but you definitely should not do 10 seconds. That's a little aggressive. And so yeah, here come the other containers. Scheduling these guys took a while, but they're coming up. Yes. Yeah, so that's a state that Kubernetes keeps. Yes. So how does Kubernetes know when there are fewer machines that it needs to bring up more, and they're not just in a rebooting state and it doesn't get stuck bringing up more and more? That's because the kind of metadata of where they are is something Kubernetes keeps track of. And so it knows where it thinks the container is, and it does kind of health checks on that. So if it thinks there's a container there, it'll keep poking around. And if it knows it just didn't update, it will probably wait for it to come up. Versus like if it hasn't received any configuration change and all of a sudden the container's gone, then it would revoke the old kind of allocation and make a new one. And they would have a different container ID entirely. I see. You want to do a custom health check? Yes. Yeah, exactly. Yes. So that. So is it pluggable? The kind of health check Kubernetes does to determine if your container is running in a healthy state, and yes, that is. And so is some of the load balancing logic is also pluggable. And, the whole thing is open source. So you can always kind of add new components to it as the community kind of needs those services. Yes. Almost setting up. Okay. Great. Yes. Yeah, so is the rolling update integrated with a pluggable policy for how many you're allowed to have down in flight? And it tries to provide tools for you to be able to customize that and specify the parameters for how long between taking things down, how many in flight, what does it mean for them to be okay. So try to customize as much of that logic as possible, because it's probably specific to your application. So, all right. So Google's been using containers for a long time, and we have a lot of best practices, a lot of do's and don'ts. And now that there are open source and publicly available kind of tools for anybody to use containers, we want to take the opportunity to come in and share what we know and kind of work with everybody to define how containers should be used at large and not just inside Google, because inside Google is a constrained problem, because Google can do a lot of things internally where when it's everybody in the world, everybody has different ways of doing things. So it's kind of a bigger problem. And, we want to be at the forefront of tackling this and share what we know, but also, work with everybody to make it the best that it can be. So, yes, clone Kubernetes at GitHub. Check out Container VMs, which is a cool new project we're doing for App Engine to use containers. And get on Freenode and contribute if this is something you're passionate about or think you know a lot about. So, thank you.
If you have more questions, remember to speak up. Okay, let him.
Okay. Yes.
Speak to Kubernetes networking model a little bit. I noticed on the website. I was wondering if you could talk about the Kubernetes networking model and different Docker model, and then where you are at for the development of that in the
Sure. Relevant to Docker in which way?
Mainly your networking model has pods that have IP addresses that Docker model. Deployment of Google Cloud was currently assigned with 35 IP addresses per pod.
Yes, that's because you can define the pods to contain multiple containers that work together. Like we were showing, you can have the shared mount where you can have a service running in one container that kind of uses a similar resource for that other container. And you want to make sure those are scheduled on the same machine, because otherwise it makes no sense to have that shared resource. And so the notion of pods is kind of a collection of containers. And we do a little bit of that mapping to show kind of how the networking should reach within the pod into like which container and on what port, all of that. Yes, that's what the backend, we showed an example with backends where we create a common service, and there is some discovery for that service where you can not know the actual address that is necessary to use that interface. You can use a proxy that will be filled in for you by Kubernetes, by the system. Yes.
So a lot of the resource allocation that was defined on the form as a really good option. It's really worthwhile to have one team person and I do about it as a common initiative and many other opportunities of service. But is there a plan for multiple teams to allow for multiple teams to increase the same?
Yeah, that's definitely possible because by having division of responsibility between containers, you can have everybody use the same Kubernetes master, and there's an API for that, and you can just have different clients. And if it's configured to use the same pool of machines, everybody will just kind of allocate onto the same pool, however necessary. If you have your team has a specific pool of machines that only you're allowed to allocate on, you can set that up as well. And you can also set up deployments across hybrid clouds. Maybe you want to use some machines from one provider, some machines from another provider, and you can set those up to be deployed specifically or separately or together or however you want. At that point, it's more of an organizational kind of division more than a technical division. Because you can do, it's pretty customizable, you can do whatever you want in that space.
I think that you can look at the document that there's a couple of, if you're really interested, there's a couple of documents So do you have any items for the
yeah, there's an API. That might be a pretty nice open source contribution. Yeah, push it into the GitHub. Can you use the mic? So one of the things in progress, and that's certainly possible, is kind of prioritization of compute resources. So you could be able to say that one pod is more important than another pod and has a larger stake to the CPU resources. And because the OS is managed, the OS can keep track of which containers, which pods are using the CPU, and we can provide that kind of throttling and allocation. But that requires a little bit of a heavier wrapper than what we have now, where we're trying to get it like very widely distributed with like common functionality. So that depends on your managed OS, its features. Yes.
Is it pretty much the same as scaling? Are there any substances from Kubernetes?
for to detect that. To spin up more VMs within the cloud. Yeah, I don't think that's something that's supported right now. Yeah, you can always add more to your pool. To itself. Sure, one more. Yes, that's something that's definitely very possible with a container deployment. And it really depends on the features of your managed operating system. So if, someone who has invested a lot of hooks and made interfaces for them to give you kind of access to some of this information of how your containers are using system level resources, it's all definitely very possible. But it's something that's kind of outside of Kubernetes because it only kind of does scheduling. But once you're kind of on a container scheduled and container deployed stack, it opens up a lot of new types of functionality for the service providers to provide cool new features in terms of managed OS features to users of containers, which is why, if you don't want to have to think about that, you don't want to implement that yourself in your VM, you can have a cloud platform provider do it for you. I'm sorry, I didn't hear. Oh, high availability. Yeah. No, please. The answer is sort of both. One is that all of those things are at the multi-master setting. You can cluster free or cluster good. We don't ship it that way out of the box. There's a couple of ways that specifically the thing that is responsible for application control. It wouldn't work if you ran multiple of them, but they kind of fight with each other. If you don't do master election amongst those to determine who should be the master, actually just check the master election code if it hasn't been wired in yet. So, you could arrive right now at integration is pretty reliable, especially on the VM where a machine failure or like a reboot. And we're pushing in a direction that will lead you to be able to actually run essentially 3 copies of the entire master stack and have them all support. And that's why I feel achieve high availability with most people definition of high availability. One last question, and I'll hang around after the last people. What are the name of the things? It has to do its own resource footprint is pretty minimal. And then it's just a question of how much do you want to use, right? The containers that you run are the things that take up the most resources. I think it's going to kind of depend on the specific application that you're running and what you bottleneck on, whether it's better to have lots of cores or lots of big machines or lots of small machines. If you're network bound, probably better to have lots of small machines. If you're actually in general, if you're throughput bound in any way, throughput or anything else, if you're running two, you're probably better off running on just really easy machines. Think that way, you'll have better data locality, you'll have any existing downloads. I think the pricing is better, to be honest. I think the cost cloud providers, the pricing is better with virtual machines. So you probably have more financial efficiency. That's true. Thanks. Thank you. Someone is really thanking Luis. Thank you. Getting kind of that set up so we can get to the talk. Jason is recording all that, so it's actually a live copy. We'll see you then. Thank you. Yeah, thanks for organizing.